Hello viewers, welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we have this problem. This is on ring analysis, okay? So, and this is limit of sequence. So we are given a sequence a of n equal to 3n plus 1 over n plus 2. So I want to prove that the limit of n tends to infinity will give us 3. Okay, so that is what we want to prove. So before we dive into the solution, please don't forget to subscribe, like, comment, and share. Thanks guys for doing so. All right, and stay calm and watch the full video on how to solve this problem. Okay, so before we start, it is very important to write out the definition. Okay, for this limit to exist, this following property must hold. Okay, so if limits of n tends to infinity of a of n equal to L, L will be the result. So this means that we must have an epsilon. Okay, so for all epsilon greater than 0, there must exist n also greater than 0, so that a small n must be greater than n, and then the distance between the sequence and the limit must be less than the epsilon. Are we together? So it must be less than epsilon. And another thing that is very important is that this n right here is depending on what? On epsilon. Okay, it's depending on epsilon. Now let's start the proof. So we know that your epsilon must be greater than 0, and then let's choose n to be what? We don't know yet, and that is what we are going to do now. So we must know n. It is very important to know n. Then how can we know n? Now let's come here, which is the absolute value of an minus L. So this will give us, your an is 3n plus 1 over n plus 2, then minus the limit, which is 3. Okay, then you simplify this completely. Your LCM will be n plus 2. So this will be 3n plus 1, then minus 3, then into bracket n plus 2. Then this will be equal to 3n plus 1 minus 3n plus 6. Minus 6, not plus 6. Minus 6, okay? Because minus 3 times 2, that will give us minus 6. Then everything over n plus 2. So 3n minus 3n will give us 0. So we have the absolute value of an minus L equals, then 1 minus 6 will give us minus 5. Then everything over n plus 2. All right. Then if you take the absolute value of a negative number, that will surely give us a positive number. So if we take the absolute value here, we are going to have 5 over n plus 2. All right. Now let's move to the next page. So this is what we have now, 5 over n plus 2. So the next thing we are going to do is to replace n with capital N. So replace n with capital N. So what we want to do is to find the value of n. Okay, so if I replace my small n with capital N, so I'm going to have 5 over capital N plus 2. Another thing that is very important that you must know, 5 over n plus 2 will be greater than 5 over small n plus 2. Why? Because we know that our small n is greater than what? Big N. Are we together? Small n is greater than big N. Now let's check. For example, so let's say small n is equal to 3 and big N is equal to 2. Let's check the one that will be greater. Will it be 5 over 2 plus 2 or 5 over 3 plus 2? You are going to have 5 over 4, which will be greater than 5 over 5. Are we together? So this will be greater than this. Take note of that. Now let's move on. So if 5 over n plus 2 is greater than 5 over small n plus 2. Now the next thing we are going to do to find capital N is to equate this function or this sequence here to be what? To be epsilon. Don't forget, want to find n, and I told you that your n is dependent on the what? Epsilon. So if you equate this to be epsilon, so we are going, let me call this equation asterisk. So I'm going to have 5 over n plus 2 equal to epsilon. Okay, so then you cross multiply to solve the problem. If you cross multiply, we're going to have epsilon multiplied by n plus 2 is equal to 5. So you can divide both sides by epsilon. So we do that, epsilon, we cancel out epsilon. So we have n plus 2 is equal to 5 over epsilon. Then you can subtract 2 from both sides. So we have n is equal to 5 over epsilon, then minus 2. Now we have the value of n. So you can now put it here in our previous page, which is what? 5 over epsilon minus 2. Now the next thing you're going to do now is to input the value of n back to what? Equation asterisk. Okay, you input the value of n back to equation asterisk. Now let's do that. So let's move to the next page. You know that our equation asterisk is 5 over n plus 2, then greater than 5 over small n plus 2. And we already have the value of our big N, which is 5 over epsilon minus 2. So we're going to have 5 then over 5 over epsilon minus 2 then plus 2 greater than 5 over small n plus 2. Okay, so this implies that 5 over, minus 2 plus 2 will give us 0. 5 over epsilon greater than 5, 5 divided by 5 over epsilon, that should give us epsilon. So we 5 over n plus 3 here rather. So we're going to have epsilon greater than 5 over n plus 2. So if epsilon is greater than 5 over n plus 2, so this implies that 5 over n plus 2 must be less than epsilon. And that satisfies the property given to us, that is, the distance between the sequence and the limit must be less than epsilon. And here's the distance, which is 5 over small n plus 2. And that completes the proof. Alright guys, so if you like this kind of video, please don't forget to subscribe, like, comment, and share. Thanks for watching. See you next time.